Alright, so for topic 3, I am going to say that this is due on Friday. So today is Tuesday. We are going to spend, we're going to spend Tuesday, today, and tomorrow, Wednesday on this packet, and then you'll have a day to get caught up, and this packet's due Friday again for either to turn in or have a quiz or something like that. Alright? I would encourage you to write this on your packet, just so that you have that information. Okay, so something got hole punched right here, and that something is the directions which say to find big F prime of x. Now, when big F, which is generally the integral of little f, okay, but here we see we actually have an equation. When you're asked to find that derivative, what theorem is this?
Second fundamental.
It is the second fundamental theorem of calculus. You have a theorem write-up part over this. Alright, the first fundamental theorem is just basically how to do integrals and plug in your bounds. But the second one has to do with when you're given an integral, how do you take the derivative of it? Alright, now remember that you don't do anything to that part. You're not deriving the tan t, you're not integrating it. It stays, so to find big F prime of x, it stays tan t. Now the only thing you have to do is deal with the bounds. Okay, so remember the first thing we do, we plug in the upper bound, tan x squared, and then we multiply by the derivative of that bound, which would be 2x. Okay, minus. Okay, now we're going to plug in the lower bound, tan 3 times what? I can barely squeeze this in over here, times 0. So that whole right side completely goes away because times 0, that's nothing. And so really, if this was multiple choice, they'd probably put the 2x in front. And I'm going to talk a little bit about simplifying today. It's not a big deal to simplify when you just get to write your answer, but when you have to pick the correct answer out, you're definitely going to need to know how to simplify. Okay. So then looking at 2, it's a little bit different because you have a function. And not like a function like x squared, but g of x. But you're going to do it the exact same way. So to take the derivative, still the tan t is going to stay the same. Okay, the bounds do not determine what you write here. You just write, the body, what you're trying to integrate or derive. You just write that, and you just write your bounds. Now, when you plug this in, don't think too hard about this. Don't think, oh, this is weird. I haven't done this before. I don't know how to do it. Just plug in g of x, okay, in for t. So that would be tangent of g of x times the derivative, which would be g prime of x. Good. All right, and then what are we going to subtract? 0. Do I even really need to write all that out? No, because if your lower bound is a number, which it was at number 1, it is in 2, and even in 3, that second part is going to be 0. You can write minus 0, or you could just leave that off completely. But either way, that second part goes away. And that tends to be pretty common on the AP test with these, that the lower bound is a number. Okay, so there's your answer right there. And that g prime of x could go in front if you wanted it to. Okay, so then we look at the next one, and this one's a little bit different because instead of having something like tan t, we just have the general function f of t. But we're not going to think too hard about this. I know, sometimes you got to think really hard about stuff. This is just, don't let this freak you out. It's the same as before. Okay, just rewrite your f of t, rewrite your bounds. And so here, you've got to plug in 2x. What is 2x being plugged into, or substituted for? T. So instead of f of t, you're going to write f of 2x times 2. Minus, I see a number, so it doesn't even matter. I don't have to write f of 3. You could, but you're going to multiply it by 0, so it doesn't even matter. Okay, and then probably this would for sure look a little bit different. They would move that 2 in front. It was multiple choice. Okay, so that was kind of a quick review of second fundamental theorem of calculus with some problems that looked a little bit different than the ones we've been kind of focusing on lately. All right, so number 4 is a good problem where you have to use the second fundamental theorem of calculus. So they give you this h. Okay, they also tell you that we're only going to deal with the x's between 0 and 2 pi, which is good when you're dealing with trig because cosine, we'll just say, tends to have a lot of answers, infinitely many answers usually. All right, so we're going to have to focus on this at some point. Otherwise, you know, like here, there could be so many minimums, we just keep finding them. We're only really caring about the first revolution, though. All right, so critical numbers. In general, how do you find the critical numbers?
Equals 0.
You set the derivative equal to 0. Okay, not the function itself, but just the derivative. All right, or you see, okay, well, where is this thing undefined? All right, a lot of functions are never undefined, so that tends to not happen on every problem, but you need to look for it. Okay, so let's go ahead and find h prime of x. So h prime of x, we're taking the derivative of an integral. This is the second fundamental theorem of calculus. Okay, so this is how it's mixed into another problem. So the t cosine t stays the same, and then the x and pi over 2 are my bounds. I'm going to go ahead and just write it below here. So I plug in x, I multiply by the derivative of x, which is 1, that's nice, that keeps it simple. And then what am I going to subtract? 0. So you can write minus 0 or you could write nothing, but either way, that whole right side is going to go away. Sure, you could write pi over 2 cosine pi over 2, but the very next thing you would write is times 0. All right. So here we have a pretty simple answer here for what my derivative is, x cosine x. So is x cosine x ever undefined? Is there anything that I cannot plug in for x? Or are there any vertical asymptotes or holes? So 0 times cosine of 0, can you solve that? Yeah, cosine of 0 is 1 times 0 is 0. That's okay. It's okay to get 0. And you may be thinking more like, where is this equal to 0? And you're on to something there. But my question was, where is this derivative undefined? Are there any x values I cannot plug in? Or any x values that cause me to divide by 0, which would be undefined? Or are there any vertical asymptotes on cosine? No. You have to check this, though. So which trig would have undefined x's? Tangent would be one of them. Okay, and all the other, like cosecant and all that has it as well. But sine and cosine are defined everywhere. All right, so let's go ahead and set our derivative equal to 0, and let's solve. Now there's a time sign here. So this is where, kind of like with factoring, we're going to set each factor equal to 0. Okay, so x equals 0 is one of my critical numbers. All right, but not because it causes the derivative to be undefined, but because it causes the derivative to equal 0. So then my next question is, what's x here? Cosine x equals 0. What's x? Mm-hmm. Who's feeling like super confident in their trig? Okay. All right. So here's what I'm going to suggest again. If you're not feeling confident about your trig, what you got to do is put down on paper what you do know. All right. Hopefully you do know what the parent function of cosine looks like. Okay. So if you need some inspiration, look over there at the top of that board over there. Okay, we got some sines and we got some cosines, and they look almost identical, except where they start. Does cosine start at the origin or at a peak? A peak. Students tend to remember this part. All right, starts at a peak, and then it does like this. Goes whoop. All right, and then once I get to another peak, I have gone one complete revolution, which is how much? And in radians, it would be 2 pi. If you can get this down on paper, you can answer this question. All right? You don't. It's not about, I would love it if y'all, like Nico could say, hey, pi over 2. I would love that. But if you can't, you got to have a backup plan because there's going to be trig on the AP test, and it doesn't matter how much calculus you know. If you can't do any trig, you're going to get stuck on a lot of problems. And so here's what this is what I'm saying. If you can draw one cycle and say that that's 2 pi, then the low point should be at pi, and then these two are at the pi over 2 and the 3 pi over 2. It's like once you kind of get it going, you can figure it out. So if I want to know where is cosine x equal to 0, it's these x-intercepts right here. In other words, I'm saying what's the x value so that the y value is 0? And so that would be x equals pi over 2 and x equals 3 pi over 2. Yes?
Can't you just use your OIO chart?
Oh, for sure you can use OIO chart. You use whatever you can. Not all students learned the OIO chart last year. And so that was something that it just doesn't work for all students. They get mixed up with it. But so however you do it, like however you've learned it, if that worked for you, great. If what you have done so far is not working, try this. If this is not working, I will come up with some other way. But you've got to be able to do these trig values. And it's not, if you're a great memorizer, that's going to save you some time. If you're not, we just got to go with what your strengths are. Okay, so here are all of our critical numbers. Okay, that's part A. Part B is finding the x-coordinate for the relative max, and part C is finding the x-coordinate for the relative min. So what this is implying here is probably one of these. In fact, one of these must be our relative max or min, or it's possible that we don't have one at all. Sure. All right, so what I'm going to do is I'm going to make a sign chart. Okay, sign S-I-G-N, like pluses and minuses. And I'm going to put all my critical numbers on there. And I'm going to go a little bit further because remember how I said we have this interval and we're only going to look between 0 and 2 pi? So I'm going to extend. You don't have to do this. You can actually figure this out without what I'm going to show you. But I think it might be helpful. I'm going to go ahead and cap that off with 2 pi. And I'm going to completely scratch out what's on the outside of 0 and 2 pi. So that we can really see. All I've got to do now is test these right here. And it's a little bit more, I think, direct. Okay, so what we're doing is we're plugging in values into h prime in these intervals. And if we get a plus, then we can say that h is increasing. And that's how we're going to determine our maxes and mins. We already reviewed this. Okay, so thinking of something between 0 and pi over 2. You can get specific, like pi over 4 maybe, or you can just say, look, that right there was pi over 2. Cosine of anything between 0 and pi over 2, that's positive, right? Correct? Yeah? So this number is also positive. So if I'm doing the angle or whatever, x times cosine of that number, I'm saying, is that positive, is it negative? Well, in this first one, it is positive. Therefore, that function has to be increasing over that interval. Okay, what about between pi over 2 and 3 pi over 2? Cosine of those values is all negative. And again, you could get specific and maybe use pi here. That's fine. But if you already have this graph drawn, that helps you here. So negative, and a negative times a positive is a negative. And this makes sense that we're kind of flip-flopping because that happens a lot of the time, not all the time. And then again, I go above the x-axis, so this would be plus, this would be increasing. And what is the x-coordinate of our max, our relative max? Pi over 2. So we have a relative max at x equals pi over 2. We need to give a justification, so we would say because h prime changes, and we need to go plus to minus. Positive to negative. Okay, so what would our relative min be? 3 pi over 2 for a very similar reason. because h prime changes negative to positive. If they were talking about absolute max and min, we would first of all have a closed interval. We would consider the endpoints. This isn't really a good example for that, but see, they actually use the word relative here so that it was super, super clear. All right, I want you to turn to number 3 on the well, actually turn to the page, and right here, if you notice, I scratched out the word normal and wrote the word tangent. Okay, normal in calculus just means perpendicular to the tangent lines. All right, it's not going to be on your test though. It is on the BC test, and it is something that maybe when you go off to college, your professor will expect you to know. So I'm just going to tell you, a normal line is perpendicular to the tangent line. So if you were able to, like, not looking at these answers, but if the tangent line had a slope of, say, 3, the normal line would have a slope of -1/3. All right, it's just like flip-flop the slope. Okay, I don't want you to do the normal. I want you to do tangent. Both of the answers are there, which kind of gives away, which well, at least gets rid of 4. All right. Okay, I want you to turn to 3, and the hole punches were pretty bad on this, so we'll just work with what we got. This, though, is just d over dx. All right, we can jump right into this and start saying, oh, product rule and natural log rule and blah, 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 blah. Or we can just look at it and say, man, that can be rewritten a whole lot simpler. I'm on number 3. How can that be rewritten? So what I'm doing here is I'm simplifying that part right there. E to the power of natural log of x squared. What does e and natural log do to each other? They cancel each other out. So what does that whole thing simplify to? Just x squared, which does become x cubed, which is super easy to derive. And the answer is
3x squared.
3x squared. And if you don't do it this way, you do a much, much more difficult problem, and you have to simplify a whole lot. So just be aware of the whole e and natural log. If you can simplify or use your log properties on some problems, you just want to be aware of that. Okay, turn the page to number 13. Okay, number 13 is asking us to derive cosine squared x cubed. What's being squared here? The whole thing. That's what that means. So I'm actually going to rewrite this as cosine x cubed, and I'm going to put the brackets around it squared like that. You're not just squaring the cosine, you're squaring the whole thing. The reason it's nice to rewrite this is because this really shows us, hey, the outer function is squared. The next inner function is cosine, and the most inner function is x cubed. 3 functions. What does this sound like? Yep, and what's that rule called? Chain rule, and it is a peanut M&M. Now, you may be able to do chain rule and not need the M&M analogy, but I'm going to go ahead and explain the M&M analogy one more time because I think it's very helpful for some of you. Okay, we have a peanut M&M. We don't crunch down on this peanut M&M. We're really patient. I think I put an extra M on that. M&Ms. All right, so we first just derived the shell, which in this case is squared. So that 2 comes down here. Then you have cosine x cubed. All that stays the same, right? You dissolve the shell, but there's the chocolate's still there, the peanut's still there. We're not crunching down on this. And in fact, I need to leave myself more room, so I'm going to rewrite this. Okay, so next we go round 2, so times. Next we just look at the next inner function, which would be the chocolate, which would be the cosine. What is the derivative of cosine? Negative sign. And I'm going to put a parenthesis there so that it's just really obvious we're not subtracting. And then again, the peanut, I'm being patient, peanut staying there. just eating the chocolate. Okay, last, round 3. We finally get to crunch down on the peanut, 3x squared. So what I want you to do is pick out the correct answer, and I want you to pick the answer you think most students picked, like, of the other wrong answers. Like, which one do you think was the most popular wrong answer? We call this the distractor. So find the right answer and the distractor. Okay, what's the right answer? D. What do you think a lot of students picked, and some of you might have picked it? A. Because, what do you forget on A? That negative. Listen, on the AP test, it's hard. On this kind of problem, leaving out the negative, you might as well not even know what to do. I mean, you don't get any more credit for knowing everything but the negative or not knowing anything. So you just got to be really careful about that. Derivative of the cos are always negative. Like, it does get more complicated when we're integrating, but a derivative of a cotangent, cosine, cosecant, those are all negatives. All right, look at number 14, and this is going to be the last one we do. And this just says if f of x equals e to the power of 2x over 2x, then f prime is. What rule are we going to have to use here? Quotient rule. All right, so I'm going to kind of work through this. We haven't done quotient rule in a while. Remember, you're going to get a quotient. And the very first thing you should write is the derivative of the top. That's how I've been teaching it. All right? And the derivative of the top is going to be, is the same thing as the top, times 2. And you could have, if you had known that was going to be times 2, you could put the 2 in front. Okay, we'll get to that. That's the derivative of the top. If you can start right, the rest falls into place. Because we know that we can't do 2 derivatives back to back. So this is where you would just write the bottom, and then plus or minus? Minus. What uses plus? What rule? Product rule. And so here, we just get to write the top, and we do the derivative of the bottom. All over the denominator squared. And none of these look like my answer. So in free response, we're good. We box and go. In multiple choice, we have to simplify. And we're going to be practicing this more these last few weeks before the test. So I'm going to go ahead and just kind of simplify out the top, and see if I can do anything with that. So e to the 2x times 2 times 2x. The 2 times 2 gives me a 4. Probably they're going to want to put that x before the e to the 2x. And then over here, okay, we need to move that 2 to the front. And what this does is just clean it up a bit. And it looks like on the bottom, I can go ahead and square that 2 and make that just be 4x squared. Okay, can I cancel out these 4's? If you do this, I will physically cry tears on your paper. You cannot do this. You can't cancel this x out with this x. The only way you can simplify from here is to factor, and what you factor out can simplify with the denominator. Factor out a 2, and what else? And e to the 2x. They both have it, right? And so if I factor out 2e to the 2x, okay, I factored out a 2, that's like dividing out a 2. The x, though, that didn't go yet, that stayed there. And then I can just stop, right? It has to be minus 1. When you factor out everything from something, think of this. You divided it from itself. You have to be left with a 1. Factoring is like dividing, not subtracting. All right, so then we have 4x squared, and what we can do now is this 2 and this 4 will simplify because I have factored it out. All right, and 2 over 4, that becomes 2, and our answer is E. If you thought that the quotient rule had a plus, you would pick D. if you got these two groups mixed up, which does happen a lot, I know with students, you would pick B. Huh?
Couldn't we just, I know that you said don't cancel out the 4s, but if you reduce the 4s and the 3s.
Yes, but what you're doing is factoring in your head. If you were to take something out of the 4 and the 2 and the 4, that's the same as factoring out. And it's not that hard to write this step, and with a number, I think, yeah, you could probably do that in your head. But when you start putting letters on it, like another problem might do, I've done this long enough that I know when students start doing that, they tend to make mistakes, and the person writing the test also does it. So I'm just going to say I think you should actually factor it out and cancel it that way, because you're never going to go wrong with that, and it doesn't really take that much more time. Okay, so let me end this.